Hi, my name is Judy, and I am a math educator from Colorado.
I'm Betty, a math educator from South Carolina. We're going to explore transformations of a quadratic function. The activity we'll look at is based on the activity Graphing Quadratic Functions. It's from 84 Activity Central at education.ti.com. Before we go to this activity, let's do a quick review of the parent function, f of x equals x squared, also written as y equals x squared. In the graph, you see several data points graphed. A smooth curve is drawn. This is continuous. And some of the points that were graphed are, for example, an x value of 0. And when we square 0, of course, the resulting y value is equal to 0. We can graph negative or positive values. Just simply substitute the value for x, being careful with the negative to put it in parentheses and square it. We could use integers, decimals, fractions. Any real number can be used for x. So thinking about the values of x, we're thinking about the domain of the function. So again, we can use any real value for x. However, when we square these values, with the exception of 0, all of the resulting function values are positive. Let's record the domain and range of this function. As stated before, the domain is all real numbers. The range is values that are greater than or equal to 0. And you saw that the vertex, which is the lowest point on this graph, this parabola that opens up, the vertex was located at 0, 0. The x value that produces this lowest function value was x, and the lowest function value is 0. The axis of symmetry is a line that could be drawn through the middle of the parabola. It would be a line about which the right side could be reflected to match the left side of the parabola. Now we're going to use the transformation graphing app to explore transformations of this parent function. To access the app, we go to the apps key and we arrow up or down to go to transform. Simply select that and then press a key on the calculator. And nothing looks different, but if we go to y equal, it does look a little bit different in our function graphing area. We're going to enter the function using a parameter a, and we're going to type a times x squared in y1, the letter a multiplied by x squared. If a is equal to 1, of course, this is the parent function. When we graph, the value of a is currently 1, but had it not been, you can simply press 1 on your keypad, followed by enter, and the a value will change to the number 1. So that's pressing a number on the keypad, followed by enter. So right now we have the parent function. Let's see what happens when the value of a changes. Judy can press the right arrow or the left arrow key, and the values of a are increasing by units of 1. Notice, however, when a is equal to 0, this is not a parabola. It would be a horizontal line, so the value of a cannot be 0 for a quadratic function. So a could obviously be negative or positive. So while these values are being changed, think about the two questions over to the right-hand side of your screen. What do you observe about the vertex of each of these parabolas? And how does the value of a affect whether the graph opens up or down? Please pause your video and answer these questions, and then restart the video and we'll discuss your solutions. As you probably noted, when the a values were changed, the vertex of the parabola was still at 0, 0. Sometimes this is the lowest point on the graph and sometimes the highest point, but the vertex remains at 0, 0. If you substitute 0 for x and square it, multiplying by any number, of course, results in an output of 0. But the value of a did affect whether the graph opened up or down. Hopefully you noted that when A is positive, the graph opens up. When A is negative, the graph opens down. Let's consider another question related to the value of A in this equation, y is equal to ax squared. How does the value of A actually affect the shape of the graph? You may have already made some observations for large values relatively of A compared to an A value of 1. Now A is larger. But what happens if the value of A is smaller than 1 but larger than 0? Judy can type a value, for example, 2 or 3/10 there, or 5/10, and press enter. And notice that this appears a little bit different from the parent function. Let's look at a smaller value, 3/10, and perhaps 1/10. But to compare it to the parent function, she's going to go back to the y equal entry location. And if you're using a TI-84 plus CE or the SmartView software, in y3, you can graph a function that will not be transformed to go along with your transform function. Let's look at the parent function. Y is equal to x squared, where A, of course, is equal to 1. And when we go back to the graph, you can clearly compare this. Now let's look at a negative value, perhaps negative 5/10. And again, we're comparing this to the parent function. Let's now substitute -6, for example, the integer -6 for A. So please pause the video, take a few minutes, and write down your answers to this question. How does the value of A affect the shape of the graph? Hopefully you noted that the shape did change. Let's look at a summary of this on the next page. You may have noticed that when the absolute value of A was greater than 1, there was a vertical stretch. It became more narrow when compared to the parent function graphed in the same window settings. If the value of A was between 0 and 1, there was a vertical compression. It became wider. Let's look at a value, for example, if Judy will change the A value back to 1/10, simply by typing 1/10 followed by enter. When the value of A is between 0 and 1, it appears that the graph is wider compared to the parent function. And the reason of that, of course, is because the y values are not increasing as rapidly as those of the parent function. Now, let's look at two graphs on the next page, both of which have the same value for A. If you take the absolute value of A, we're looking at y is equal to 4.6x squared opening up, and y is equal to negative 4.6x squared opening down. Notice that the graph that opens down is a reflection across the x-axis of the graph that's opening up, but they both have the same shape. Now let's explore another parameter. We'll change the parent function in a different way. So we'll go back to y equal, and this time we'll look at transforming the equation y is equal to x squared plus a constant, x squared plus c. And we'll delete the parent function for now. So let's look at the graph of this particular function. The value of c is currently 0. If you're using a calculator or the software and your value of c is not equal to 0, simply press 0 followed by enter. And then you can change the values of c, as Judy is showing, by pressing the right or left arrow key. What do you observe about the vertex of each of these parabolas? And how does the value of c affect the graph? Pause the video, please, and write down your answers to these questions based on the changes that you see in the c value. You may have noted that the vertex in this case does change for the equation y is equal to x squared plus c. For the parent function, the vertex was 0, 0, but if c is decreasing, the y value of the vertex also changes by that amount. So in this case, the vertex is 0, negative 2. If the c increases, the vertex, again, has a different value. And you can see that by looking at the graph. For example, if c is positive 3, then you would see that the vertex is located at 0, 3. And this also gives a hint to the second question, the answer to the second question. The value of c seems to move the graph. It translates it upward if the c is increasing, and there's a translation downward if c is decreased. Now let's do a challenge for you. Provide a challenge in this case. You're given the equation y is equal to 3x squared. We'd like for you to describe the graph of this function. You may also wish to sketch the graph. Clearly, the 3 is different than the value of 1 in the parent function. It's a coefficient of x squared, and the constant in this case is negative 2. For other videos, please go to the TI Education YouTube channel. Thank you.